Hi there, welcome back to Chapter 2 of our series on how ionir works. In Chapter 1, we talked about the metadata database and how we separate location from name or content in the addressing of data, which is really the core secret sauce behind the entire platform. In Module 2, we're going to talk about how that technology is applied to the movement and copy of data across distance or across clusters. As you know, we can move any volume, regardless of size and capacity, across any distance in 40 seconds or less. So we're breaking and bending the laws of physics here. And now we're going to get into exactly how that works. Now, what's interesting about this is, let's say we wanted to move the data from one location to another. It's a very simple process to do this. And here are the steps involved. There are 4 steps involved, and I'll walk you through them slowly. But based on what I just showed you about how we create and maintain blocks, it should be fairly easy to understand. Remember, in Washington, D.C., on volume 1, this is what we've been writing to so far in our example. We wrote 974D and we wrote CB45. So those physical blocks exist out here. And of course, before that, many, many other blocks were written that we're ignoring for now for this example, but they're there. Okay, so we want to now move a copy of this data to Dublin, let's just say. First thing that we do is in Dublin, we create a new metadata database. I call it a recipe for volume 1 in Dublin. If we were to try to read and write to this at this point, all of the data for volume 1 still exists in Washington, D.C. That wouldn't be very efficient. Not really the way we want to do this, but I guess it could work. But what we do instead is as soon as we establish this metadata recipe for volume 1 in Dublin, we move over a few hot blocks and their neighbors to seed the Dublin volume 1. Now, this is a very quick process. It's only, a few seconds. It takes 40 seconds altogether to do both of these, to establish the metadata and then to create the block store seeds over in Dublin. So what we've done is we've taken small little groupings of what we believe are the hottest, most frequently accessed blocks and moved them over. As soon as we do that, 40 seconds later, we have volume 1 in Dublin available for mounting and for full read-write access from the applications in Dublin. So this exists, it works just fine, and it reads and writes perfectly. All writes from that point on to volume 1 Dublin occur in Dublin. So if we were to write another application change in Dublin at, say, 45 seconds past 5 o'clock after this volume 1 has been established in Dublin, we would write blocks of data in Dublin. And all future block writes would occur in Dublin. So there's no write penalty associated with copying this data and creating this volume in Dublin, because we're maintaining all the write blocks, the newly written blocks in Dublin. Now, of course, there will be a slight read penalty if you try to read from one of these areas where we have to go back and get the data from Washington because we don't have it in Dublin yet. But every time that happens, if it does happen, we'll go and grab a handful of blocks and bring them back over to Dublin and along with the block that we wanted, and refresh a portion of the block store in Dublin. So it helps to continue the seeding process. As well, in the background, we run a process that moves all the relevant blocks from Washington, D.C. to Dublin. I'd like to call it rehydrating. We rehydrate volume 1 in Dublin. It happens in the background. Priority is driven by the heat map, so the hottest blocks are moved first. What we believe are going to be the most frequently accessed are moved first. you can control this, how fast you want this to occur, based on policy. So that's how we kind of bend or break the laws of physics. We create a volume that's fully read-write accessible in Dublin in 40 seconds or less by creating a metadata recipe for it, seeding it with the hottest read blocks that we think will be accessed first, and then very quickly filling in the background blocks that as we rehydrate it. So it works just great. And we have a demonstration of this occurring on YouTube. If anybody's interested in seeing it actually being done live, it's very simple and very straightforward. It's really a one-click process to start this all off. And 40 seconds later, you have a volume mountable in Dublin. Okay. And then once we get it rehydrated, of course, then the volume exists in London and all reads and writes in Dublin, and all reads and writes will occur in Dublin.